Hello, welcome everybody. I hope you can hear me okay. Go ahead and adjust your speaker volume, maybe mute your microphone, and let's get started here. If you notice in your top or in your control panel there, there's a tab for questions. Feel free to ask any questions you guys would like. I will get to them at the end. The first session had quite a few questions, so it was a lot of fun, and hopefully this session does as well. All right, well, let's go ahead and get started. Today's webinar is on my controller is certified, or is it? Really, how this webinar came up is I'd say like 2017 timeframes, really only like a couple years ago. Motor controllers became a hot topic, and it was a hot topic because everybody thought that they were using certified equipment in their systems. In reality, when we started looking at them, they were using certified equipment, but it was certified for machine safety, and it wasn't for the process industry where it would be used in, like, let's just say, a low demand application. And so we're going to talk about that today. My name, like I said previously, it's Ted Stewart. I do work for exida. I'm the program development and compliance manager. I have a little over 10 years of experience in safety and high availability automation systems, manufacturing, lean process improvement. My background quickly, I started my career with Lockheed Martin in missiles and fire control in Orlando, Florida. I was a test engineer. I had a lot of fun there. That's where I first learned about Six Sigma, lean process improvement, Kaizens, and I got my green belt there. I then moved over to Harris Corporation, kind of like a sister company. I worked for a group called Wireless Products, where we basically made little black boxes that could locate and track people. I was responsible for 14 different classified products, and it was neat because that's where I started learning about the safety life cycle. I was able to watch products go from their the beginning stages all the way to when they become obsolete. And because the industry that I was in with Harris, the product life was only about a year long, so you had to develop it the previous year. It was active for 1 year, and it was obsolete by the end of that next year. And so it was extremely fast paced, but it was very helpful to get me to where I am today. Today, I now help manage the OEM certification division. I'm the deputy quality manager and the director of the CFSP program, so I stay very, very busy. I wear a lot of different hats, and the compliance manager portion, the program development, that comes into play because whenever we're looking to get into a new industry, whether, hey, it can even be motor controllers, but cybersecurity as well, they kind of look to me to try and help break into the industry, obviously with the help of a lot of our other employees here as well. So, okay, that was enough about me. I got 2 or 3 slides on exida, and we'll jump right into it. But we are a global consulting and certification firm. We do have offices all over the world, and every year we are opening up a new office somewhere, it seems like. This year was Mumbai, India, and that has become extremely successful already, which is exciting to see. The portion of our services and products here that you see in front of you, I don't want to call them silos, but they kind of are. We have a consulting team. We have engineering tools such as Excellencia. Today we'll talk about product certification. We have training, reference materials, and of course, if you're looking to get yourself some training, we have personnel certifications as well. How are we doing? We always get asked this question by a lot of our customers, kind of because you always want to make sure you're teaming up with somebody that's going to be here forever, or going to be here for the long road. We started this company in '99, like the 2000 time frame. In 2015, ARC did a report on the certifying bodies, and this is what you see in front of you. We're that blue piece of pie, and so we're doing very, very well, especially even in the logic solver category, which is what people usually base their decisions on. We were the leader of 44%, and that's in 2015. And then 2018 came around, the report got updated. We were even curious because we want to know, well, who makes up the other portion of that pie, so to speak. In this chart on the right-hand side, we are the red piece, and then you can see all the different colors, and then there's percentages underneath. And that's 2018 for the logic solver certificate. So yeah, we were very excited. So quick, just to let you know, we will be here for the long run. We're doing extremely well. It's very rewarding to be working for this type of a company, but we have some phenomenal leaders in place that are really paving the way for us. Okay, let me put on my motor controller hat and today's abstract and why everybody on this call is here. I'm going to read this abstract just to get us all on the same page, and then we're gonna dive right into it. So in the process industry, many safety functions, they include what? They include a pump, a motor, or other electrical device. Now, to bring a process to a safe state, that device or the devices that control these electrical elements, they need to work correctly. Most designers choose what? They choose the SIL certified motor controllers, motor relays, contactors, and drives. However, this is where things get a little misleading. Some of these certificates look good, but they list IEC 61800 or ISO 13849 as the standards are used. And that's not a bad thing. But if it's somebody looking to maybe put this in a safety function in a low demand application, that's not a good thing either, because most of these certificates provide cycle test failure rates based on frequent cycling, right? So that's for your high demand applications. And high demand SIL certifications are prevalent for machine safety where the device or the elements are moving frequently. But when dealing with systems in low demand, there is a large void in the process industry. In 2017, I think it was January or February, I did go to the Motor Controller Conference. I gave a discussion there. And it was eye-opening to listen to the audience on the questions that I was receiving, because there truly was a lack for failure information in a low-demand application. So, and so that's what conducted even the survey that we started doing, because it showed in the survey that I'm going to share with you, it showed the lack of that data. And we're really trying to figure out, well, what are people doing if they're putting these motor controllers in safety systems, but there's no failure information to back it up? How are they putting these things into the system? And to cut to the chase, really, people are saying, well, we kind of just designed it out of the safety function. We just didn't include it because we didn't know how to include it in the safety function. And that's why we keep talking about it, and that's why today's topic came up. I'll explain to you how I define what a motor controller is, just so when I'm going through this webinar, we are on the same page. I'll share with you that marketing need for safety controllers. We'll talk about the certifications and knowing if that certification, that SIL device, is actually right for you and for your system. How to evaluate a device for a system, and then of course, well, what happens if all the above can't be met? What do I do to fill the void for the near term? So I hope that's okay for everybody. All right, so when I talk about a motor controller, the first thing you do is, okay, what's the definition of one? Well, even that is a broad approach, because one definition you'll see, and it's very basic, it'll say it's a standalone device that can perform control logic and decide when a motor should turn on and off. Simple enough. Yeah, that's a motor controller. But let's elaborate a little bit on that. What if it's a device or control of devices that serves to govern in some predetermined manner the performance of an electric motor? A motor controller might include what? A manual or automatic means for starting and stopping the motor, selecting forward or reverse rotation, selecting and regulating the speed, regulating or limiting the torque, and protecting against overloads and faults. That's a much more robust definition. I like that one more because it kind of explains better what a motor controller is. But if you want just a top level approach, you could just say it's something that decides to turn a motor on and off. However, because of the gray area, there's so many different types, and there's a lot of common motor controllers. So I kind of broke it into 4 different groups here. The first one I called relays. The relays are what? Their operating principles are either the electromagnetic, they could be solid state. A relay can be such like an overload relay. I have a picture there of the Rockwell E300. That's an electronic overload relay, and that's basically where it has electronic overloads that offer a reliable and precise protection for motors, really in the event of the overload or that phase failure. And the electronic overload relay can make up really a compact starting solution together with contactors. And so when I talk about contactors, I'm talking about it's something that's a type A device, which means that it doesn't have any kind of microprocessor. It's a simple device that doesn't think for itself, which in comparison to a relay, it's designed to handle really more current. And it can be either a single pole, it could be a 3-pole device. What else can I tell you about a contactor? It usually has a coil to energize and really pull in the assembly and makes that contact to, excuse me, to the control signal, which kind of hints the name contactor. And then when you talk about a contactor or a relay, we see it as part of a motor controller. All right, so it's not a motor controller itself, it's part of it. Now, if you move over to the right side of the screen, you talk about starters. A motor starter really has more functionality than a contactor, and it can either be a type A or a type B device, right? There could be microprocessors within there. And now these products, it limits really the inrush current and mechanical torque at the startup operation. Because of these control function, it really helps prolong the mechanical life of that motor and reduce any kind of voltage dips. Currently, the motor starters in the field, there's rather a large variance between these products. They have many different capabilities, as we speak of, but what we've realized is there is not a lot of 61508 data available. But we do have some generic failure rate information in Excellentia, and I'll share with you closer to the end when we talk about what do you do if nothing is certified and you can't find anything, because this really didn't start ramping up till 2016, 2017 at least. Okay, maybe it's just from my eyes, but I really feel as lately there's been such a high demand on trying to find failure information in low demand applications. And there are a few key players that have really started to take this serious and are starting to get products certified. Motor drive, I found two different main types of drives. One was a safe torque off. It's a function that keeps the motor from restarting once it has been stopped due to a failure of some kind. It's one of the many functions that can really be built into these motor drives. And then the other one would be variable frequency drives. We see these as the primary type of drive system for those modern controllers where that variable of speed is actually needed. How it works is they basically use a rectifier to turn AC power into smooth DC current, and then they turn it back into AC current at a determined frequency using some type of inverter, let's say. So those are my quick definitions. So when we looked, we created this market survey, and we wanted to know, is there a need in safety applications? That was one of the first questions we asked, and you see here in front of you, it was demanding a very affirmative yes. 94% of people said, look, there is a need for this type of safety function. It's like, okay, well, great. That's fine that there's a need, but we need to continue. We need to dive a little bit deeper, and we said, okay, well, what kind of electric final elements are there? And what we did is we looked and we found out is 16% of all SIFs that were being conducted. So that's really like 1 out of 6 relays on a final element. 1 out of 6 are people using these motor controllers. So really, when we saw that, we're saying, okay, yes, there is a true need. People are trying to use these in systems. We just don't know how they're doing it, or what do they want to look at when they're trying to determine if it's right for their system, right? And so that was another question we asked. Well, okay, fine. Well, then how do you evaluate a device to use it in a safety system? What are you looking for? And given that there is this need for motor controllers, how do the engineers who design these systems and select the devices, what are they evaluating for them to use their product? We asked that question, we said, look, when selecting equipment for the use in the safety instrumented system, what criteria do you meet? Do you accept to meet the suitability of it? Well, the first thing they said is, look, we would love to see IEC 61508 certification. The next thing is, we'd like an FMEDA report. We'd like to see the failure information. Makes sense, right? And there's some other things there as well. So we saw that response saying, okay, we want 61508 certification. The question is why? Okay, why are they looking for it? And there is an answer, but that answer can be misleading. And that's what kind of led us to here, because people are saying, okay, if I can find a motor controller that's IEC 61508 certified, I can use it in my application. That's not necessarily true. Because you don't know how that was certified to begin with, because the first thing you want to look at when you want to know if you're going to use a product for your system is look on that certificate, or look and see if it talks about PFDavg or does it talk about PFH. Think about how you're going to use your product, right? Because do you expect the frequency of demands for your operation made on that safety-related system to be no greater than one time a year? If that's the case, then okay, we're talking about a low demand situation here. You're gonna be more focused under a PFD number, right? However, if you expect that frequency of demand for operation made on that safety-related system to be greater than once per year, then you're gonna be talking more about high demand, or even some people call it very high demand, or continuous mode, right? So that's the first thing you looked at. The second thing you want to look at is, okay, what standard is it certified to? Because what you'll notice is you'll see sometimes it's IEC 61508 certified. Well, that could be just the umbrella standard, but you have to dive in to see, okay, really, what did they do to get that product certified? It doesn't matter if it's a contactor, a relay, a motor starter, because you're often going to see these things advertised as certified, but 99 out of 100 times, I'd say, they're going to be certified to machine safety standards. What are those? That's IEC 62061, 13849. There's others. There's another motor controller standard, IEC 61800. I talked about in my abstract. Now, this does not impede on the certificate, right? It doesn't say that the certificate is no good, but it really should be a red flag for anyone that's looking or needing to use a product in a low demand application. Because if it's to the machine standard, I'm going to say 99 of 100 times, it's going to be for high demand only. And that is that's the misnomer, is people are looking, they're seeing things certified and they're starting to use it, and they're going to use the failure rates, if there are any, associated with that certificate, and they're thinking they're doing a good job. In reality, they're actually creating an unsafe system. What's another thing to ask? Well, let's now dive into the failure rates with that certificate. Are there certificates? Are there failure rates on that certificate? If they're not, that's another flag. You should say, well, why do I not have the failure rates? If they're just giving you a PFDavg number or a PFH number, remember, there are 9 different variables when calculating this equation. So if you're looking to do your PFDavg calculation and say, well, they gave me mission time, that's not enough. And mind you that, okay, yeah, sure, they say mission time is 20 years or something like that, but what about your proof test interval? What about your proof test duration, your site safety index? Where are those assumptions coming in? So if a manufacturer or certificate shows a PFD number on that certificate, that's doing you a disservice, because that's saying, look, you must use it exactly like this per this calculation if you want to use this number. In reality, you really should be looking for just the failure rates and looking to ask for that FMEDA so that you can make sure that it was done with your best interest. Another question you want to ask is, look at those failure rates. If you get those failure rates, you need to see, okay, because if it was an FMEDA done, normally that would be for a low demand situation. But if you have failure rates and they use something called B10 data or cycle testing, that's completely different. Now, when we talk about failure rates for a low demand or a high demand situation, there's different factors that come into play too. It could be the different environmental factors, right? And it could be a different technique on even how they came up with those failure rates. So let's say, for example, they talk about low demand failure rates. Now, these are normally calculated using what? That FMEDA approach. I'll talk about what an FMEDA is here in the next couple slides here. And a high demand failure, like I said, they're going to calculate by that B10 approach. The B10 approach is basically, think of it like this. It's a measurement of time by which 10% of the population of that product have failed or will have failed. This term really came from the manufacturer of anti-friction bearings, and it is used to express really that minimum lifetime of 90% of a given batch of bearings operated within, let's call it, speed and load tolerances. And so that's how they got that. So anything that they want to do wear out, so that's why it's high demand and continuous, they're going to use a B10 approach. And low demand, you have to do more of a predictive manner, and that's the FMEDA approach. If you talk about low demand, there's other things that come into play that high demand does not. In low demand, you have to start thinking about things like stiction, corrosion, cold welding, and really any kind of binding. And these all play a large factor when we talk about low demand. So if someone is using a certified controller and it's meant for a high demand application, and they're using in a low demand application, then really those failure rates are going to be very optimistic, and it's really going to lead to a dangerous result. And so we couldn't stress that enough. Now, when a product is going to get certified, you're going to find out that there are 3 barriers, right? That an end user is going to have to get through if they're going to have to certify it themselves, or at least provide that justification when they're looking at 61511. And here are the 3 different challenges, right? So when a SIL level of a product is determined, the system capability has to be looked at, the architecture constraints need to be looked at, and then of course the PDF average calculation of that product. Those are the 3 things that need to be looked at if a customer is trying to achieve a SIL rating for a SIF. Let me touch real quick on each one of those hurdles. The first one is the systematic capability. Now, this is established by having your quality management system audited per 61508, right? This is me speaking to a manufacturer. And if that quality management system meets the requirements of 61508, that SIL capability rating is issued. And the rating is achieved, it really depends on how effective your quality management system is. So things like, how you source your part suppliers, how you make modifications, how returns and recalls are handled. All of these things are considered at this point, and the certificate itself is for the systematic capability of that product. Now, when that motor controller becomes certified, the systematic capability of this device is now shown on this certificate. You can see there, right? You see that big red arrow. Because without this product certification, this barrier, it really does become hard for an end user to meet it. They'll need to go through a proven in use justification. This usually increases, basically cost, right? Because your time and money now are consumed. If a manufacturer did get it certified by a third party, now it ends up being a huge selling point. Why? Because now this end user doesn't have to go through any of that work. They can simply ask for the documentation, get the justification, and keep moving forward. The second hurdle that they'd have to face is the constraints, the architecture constraints. There's 2 different ways you can do this. You can go route 1H or you can go route 2H. In the evaluation of a motor controller, the device will be elevated based on its architectural constraints. Now, this is either by the complexity of that device or by field operating history, okay? So these 2 different things, one's route 1H and one's route 2H. You can even do it by both if you really wanted to. It seems the trend is everyone's going towards route 2H. Now, there are different SIL tables in 61508 and 61511 to determine the architecture constraints. It really just depends on the SIL rating the end user needs for their SIF, right? Because they're going to end up going through, calculating their risk reduction factor, and then they'll plug in their equations to figure out, do I need a SIL 1, a SIL 2, a SIL 3, or maybe I don't even need SIL to begin with. Once again, going back to the certificate, when the manufacturer has that product that is certified, you can see here that on the certificate, it even talks about you see HFT on there equals 0. That's the hardware fault tolerance. That's really redundancy. So this is saying this is a SIL 2 capable product with 0 redundancy according to Route 2H. And it's very helpful because now what you just did is you told the end user how they can correctly use this product in their system. The next one here is your PFDavg, right? Your calculation. This was the third hurdle. Remember when I told you that there's 9 different variables to achieve that probability of failure on demand? A few of those is that it's going to be based on your dangerous failure rate. There's system diagnostics. There's proof test coverage, test intervals. There's maintenance and other conditions that are really controlled by both your product and how your customers use this device or element. It can be from the product certificate. The end user can really just take these failures of the device, and with the knowledge of the variables that they control, right? It's not what the manufacturer controls, it's what they control. such as really like how often they want to test the SIF or how they can calculate that PFD average for that SIF. And it's just so important, and I can't stress this enough, that that PFD average is not a value that that manufacturer should be providing. Sure, I see it all the time with machine safety, but when we're talking about when people use these in a low demand application in the process industry, it is absolutely up to the end user to do this calculation. If you want to look at your certificate, once again, this is on the back page of ours. We do publish those failure rates based on those predictions. This is the most critical piece of information for end users because now they have the information they need to calculate their PFD average number. If this is not on one of those certificates, I feel as though that certificate is incomplete and they need to go back and get these numbers for those end users, because without this information, that end user, I mean, how do you calculate a PFD average if you don't have all the information you need to calculate it? Providing a PFD average number to an end user is almost useless. It really, really is, unless you want to be able to use that product only the way it was specified and only the way it was calculated. All right, so we keep talking about these failure rates. So how are these really derived? I got two quick slides here on the FMEDA, just because there's always new people on here that may not understand what an FMEDA is. I can kind of shed a little bit of light on the subject, really just go into the basics. Like if you remember back in school and you go back to the topic on reliability, it said, that the failure rate of a series system is the sum of the failure rates of the components, right? Makes sense? So that's really the essential concept of an FMEDA. It stands for failure, mode, effect, diagnostic analysis. It's a globally accepted approach, and it even can be used for new designs. And really what an FMEDA does, it's basically a study done on the design strength of that device. And it really looks at the failure rates of each component and how that component can fail and how it affects that device when it fails. So because it's a predicted approach, these FMEDAs need to be calibrated. Nothing that the manufacturer or the end user needs to be concerned with, but this is something that I know specifically our certifying body, what we do is, and I can only speak for ourselves, I don't know many others that actually calibrate their FMEDAs, but what we do is we take SILSTAT, we'll take other industry databases like ISPM, ORITA, and anything that's published data. We'll take all that data, and then all the field data that we collect from end users, when they're actually using the products, we'll take actual data, we'll take our predicted data, and we'll look at it and compare it and make sure they're lining up with one another. If by any chance that there's a delta and they don't line up, we update the numbers to make sure our estimated results and our predicted results are meshing together, right? And then that's how we develop this database. That's how I keep developing FMEDA. So like if we do publish an FMEDA on a product, 3 years later, it has to be renewed. Well, if there were significant changes in the product, maybe technology, right? Maybe products are getting better, so the failure rates can come lower. If the technology is getting worse, then the failure rates will go up. But these FMEDAs are always updated so that you can get the best realistic numbers as possible by using a predicted approach. The next thing we say is, okay, well, the next thing on our agenda was, okay, this is all well and good, but what if we're trying to use a manufacturer's product? Maybe it's certified, maybe it's not, maybe it's to a machine safety standard, or like I said, maybe it has nothing on it, and there's no field failure data available. What do we do? Well, there's a website called silsafedata.com. This is at least your starting point. This is where I kind of recommend everyone go to if they can't get their manufacturer to at least do an FMEDA in their product. If you ever want us to talk to any manufacturer, let us know. Or if you are a manufacturer, send me a quick link. We can work with you. We can figure something out. Because really, those that get this work done sooner than later are going to be way ahead of the curve. Because this is where everyone's going. Everybody's looking for this data. Every time we go to a conference for a motor controller or anything like that, this low demand data everybody wants, and they'd be buying the products if they had it. So how this website works You can see here when you type in the website, it basically takes all the field operating hours. It has the databases, all the different FMEDAs that have been created, and it combines everything and it makes an upper and lower bound for your dangerous undetected failures. What that means is it's going to be generic, right? So it's going to be conservative. These will be conservative numbers. So any product that actually goes through the process and gets an FMEA done, those numbers are going to be lower most likely, right? We'd have to see, but there's a higher chance for them to be lower and more effective than just using generic data. And when you scroll through and you find the motor controllers, whether it's a contactor, a relay, a variable frequency drive, you can see here's your lower limits and your upper limits, and you really want to use the upper limit as your generic result. Why? You want to be conservative because if you really don't know how that product's going to operate and you do not know all the failures and there's no FMEDA done it, you want to be conservative, especially if you're designing a safety system. And that's always critical. Never be too optimistic. Always be more conservative, especially when you don't have the information that you need. So if I could real quickly recap, I just want to reiterate the fact that there is a misnomer out there right now, and we're seeing this come through a lot where people are thinking that they're using certified equipment in their systems, not realizing that even though it says it's a 61508 certificate, SIL 2 or SIL 3 capable, even SIL 1 capable, they didn't realize that those numbers came from the machine industry, and it's for a high demand and continuous certificate. And that is a huge difference there. I know Rockwell, they got their E300 certified. They're working on some other products to get certified, and that's only going to strengthen our marketplace. We have a few other people that are starting the process right now to get their motor controllers or motor relays, contactors, things like that to get certified. But the one that I can mention is only the Rockwell E300 because I know that one is finished and it's a public product, or certified, so that way it does become public once it gets finished. Real quickly, 2 different slides here, then I do got a bunch of questions. Awesome. If you're looking at any kind of training, just the things that I wanted to note is you can now do online trainings. So if your travel budgets got cut for whatever reasons for Q1 for 2019, here's some things. Some of them are online, some of them could be next to you. I always like in-person ones. I feel like you can learn more. I love the instructor being right there one-on-one with them. But there's some training dates. If you don't already follow us, you may as well. We're always giving away free stuff, whether it's white papers, topics, sometimes even coupon codes. I don't know. But it's always useful to follow us. We're always doing as much as we can for people. And happy holidays, everybody. Let me go ahead and start answering some questions. Man, I can't believe it's right around the corner. I have so much work to do. All right, so here we go. The first question I have here. Do we need to consider PTI for a high demand motor in low demand applications? PTI, proof test interval. So do we need to consider proof test interval for a high demand motor in a low demand application? I would say yes, because you're going to need your SIL verification, and that's going to be done based on really a demand rate. And so that's what I would say with that. That's a interesting question by saying a high demand motor in a low demand application. But in reality, yeah, you're going to want to do your SIL verification based on that demand rate. All right. If a component certificate claims full IEC 61508 certification, but doesn't mention systematic capability, can you assume systematic capability? Would a prior use justification be needed? Oh, that's weird. I would say no. I would say no, that something is wrong with that cert. If that's what you're seeing, I would honestly just contact that manufacturer and ask for a complete cert. That's really strange if it doesn't mention systematic capability. You really just can't make that assumption at all. Huh. I'd be curious to see what that cert looked like. Just to clarify, assuming this application has failed, the evaluation is about the controlling device. For the person that asked that question, it's really not clear. Send me a quick email and I will get back to that one. How do we be sure Route 2H certificate has enough data from field return? This is something the certifying body must verify. I can speak for our company. Exida uses 10 million hours. What I'll do is I'll put a link to a white paper on the criteria for the application of 61508 to the 2010 standard for Route 2H, and I can share with you that white paper. Everybody, oh, by the way, everybody on here is going to get, I'm going to create a PDF with all the questions that were asked today throughout both sessions, and I'll personally email you the answers to all of these questions. That way, if you're taking notes, don't worry about it. You're going to get a PDF with all these questions and the answers. Any reason why data sheets in Silver do not include demand mode? How do I know if the failure rates are appropriate to my application? Ooh, interesting question, Sebastian. If you don't mind, I'll take that one offline and I will research that and find that answer out for you. I'm not familiar with Silver, but I will absolutely take a look at that. All right. SCRH does not have much information on electrical elements such as relays, contactors. When will they be available? Oh man, wouldn't you like to know? Because I would like to know too. Well, that information will be available as soon as we can get some manufacturers and end users providing the data. We do have generic failures or generic data for those types of devices. They are not an SCRH because we need manufacturers to start getting their products, at least get an FMEDA done, because as soon as we do, those things can go into SCRH. The only thing I can tell you for now is that this is as good as it gets right now, except, like I did tell you that one product, the Rockwell E300, that will now be updated. It'll get an SCRH, and that's at least a relay with some information, and I know that they're working on a contactor as well. So it's slow, it's coming. Mario, you will start seeing more of this information, and as soon as, just if you want, you can either keep emailing me, and I can only tell you with the public information that I can tell you, but just know that this information is coming more prevalent. More companies are coming around and getting FMEDAs done, and I ask everybody on this call, whether you're an end user or manufacturer, please let me know if you're interested in trying to help with this so that we can get things moving quicker. Getting PDFs to the questions is an excellent idea. You're very, very much welcome. I'll send that out to you. No problem at all. Yeah, I'm glad you like that. Thanks. This is kind of the same thing. How do you determine failure rates if it's not certified? Like I say, go to silsafedata.com and you can get and you can at least get a generic number, or if you can get me in touch with that manufacturer, or if you are a manufacturer, get in touch with me and we can see if we can assist you and get that information. Okay. If the overload or outputs are not being used to control the start and the stop of the contactor, I would assume that it's not used in the calculation of the SIL capability level of the SIF. What I'll tell you is that if parts are not used in the SIF, do not include them in the calculation. So that would be correct. So if it's not going to be used in the SIF, then you do not have to include it in that calculation. That is correct. If a manufacturer gives you a PFD and they tell you that the mission time is 20 years, can that data be used without failure rate data? The short answer is no. There's going to be those 9 variables like I spoke about. They're going to be used to give you that complete PFD calculation, and without knowing those variables and assumptions, you really can't know the lambdas. This is another white paper that I know we have. I'll put a link to that white paper in the PDF, and they're free, so you can just simply download it and you'll have access to that up for the PDF. I have a question here. Would you please elaborate on the systematic and random capabilities are done under controlled conditions it might not reflect the actual operating conditions. And the FMEDA basics and the total equals the sum of the individuals. Would you please elaborate? What I can do for you, that's not, I'm kind of more of a visual. I can kind of give you more through a visual answer. If you don't mind, I will take that one offline and I'll throw that into my this PDF that I'm creating, and I'll draw that answer and I'll let you know my view on that, on basically what I would do in that situation, if that makes sense as well. That's a good question. I just need I need to elaborate a little bit on that one and get a more visual approach. So I can answer that one live. All right, those are the questions, everybody. Hey, thank you so much. I know it's crunch time. We're all at the end of the year, but I really appreciate everyone's time and being on this webinar with me today. I hope you guys have a very happy holiday. If you already had Hanukkah, I hope that went well for you as well. And take care, everybody. This was our last webinar of the year. I appreciate it. Thank you again. See you next year.